Okay, so we can start. Okay, so good evening. Today we are going to discuss about the topic export to robot structure analysis. So before that, let me introduce myself. I'm Sri Lakshmi, working as Junior BIM Application Engineer at BIMLABS Global. So I'm from Structural Department, and I'm a certified Autodesk certified user and Autodesk certified instructor. So before getting into our talk, this is what BIM. So hope everyone know about BIM, that is building information modeling. It's actually a process of creating and managing information of any built asset throughout life cycle of a building, not building of a built asset, anything. So from planning stages to designing construction and at last we're at operation stages. So actually BIM has variable disciplines we can execute BIM. So our topic is actually a part of structural BIM. So we have several disciplines like architecture, structure, infrastructure, construction, MEP, etc., etc. So coming to structural BIM, in structural BIM, we are creating a 3D model-based process that enables the structural engineers to design, document, and fabricate structural systems more effectively. That means a structural model represents a 3D modeling which having structural components like what beams, columns, slabs, footings, etc., etc. So coming to our topic, export to robot structure analysis. So here we are using two softwares for doing this activity. That means one is Revit and next one is Robot Structure Analysis Professional. Okay, so basically robot structure analysis is a analysis software. Now we are actually using robot structure for what? Exchanging data with Revit. Okay, so coming to today's topic, we are going to discuss about the interface and the workflow of software and exporting a loaded model from Revit to robot structure analysis professional, then take analysis, and then about taking result. Okay, so before that, I will just show you about the software. Revit is actually a common software, as we all know. So coming to robot structures, I don't know whether you know that software or not. Okay, just a minute. Okay, so here, as I mentioned earlier, we are using two softwares, and one is Revit, and next one is robot structure analysis. Okay, so let me show. So this is software we are using. Okay, robot structure analysis professional 2023 version I'm using, and also I'm using Revit 2023. So in the case, as we all know, means actually what? In simple words, we can execute all the process of a typical project using a set of interconnected softwares, right? So that is actually the concept of BIM. So here we are exchanging data from Revit to where robot structure analysis. So actually robot structure analysis is a purely analysis software like STAD or ETABS or any other analysis software. The workflow also very similar to other analysis softwares. But today in our session, we are not doing a fresh model and analysis in robot structure. We are just exporting data or exchanging data with Revit. Okay. So window of the structure analysis. So if we want to start a new project from where from no option we can start it, or like we can open a project we can see some sample models over here. So these are the templates in the software robot structure analysis. So the first one is building design. Suppose we are going to do a content model, we can use this one. Or if you are uh, going to do, like, the second template belongs to also RCC. And coming to third one, it's shell design. And coming to fourth one, it's a frame 3D. That is mainly we can execute for steel structures. So, not this much template, more templates also available. Okay, we can access after opening the software. So now I'm just roughly using this building design. So after set choosing a particular template, we can change it later. Okay, so this is actually the interface of the software. Okay, let me continue. So coming to the interface of the software, so which is much similar to like a software of Autodesk. Like here we have title bar, and coming to the right we have information center, and here we have application menu and like file, edit, view, geometry, logs, analysis, etc. here. So those are what menu bar. And here we have some of the tools, and the balance tools are arranged in right side. And here we have object inspector, like similar properties or project browser in Revit. Here we have object inspector, and this is our GUI, that is graphical user interface, that is our model space. And come here, from here we can change to 3D or XY or YZ or XZ 2D planes. And here we have some view ranges are available. So that's all about the interface. If we want to change the template, we can go to geometry, and from there structural type. We have several templates there available right here. If you are doing mostly for concrete structures, we can take its building design, and for steel structures we can use frame 3D. If you have specific one, for example, I want to design a truss, then I can use this one. Okay, so various options are available over here. Okay, so this is actually a simple introduction about the software. Now I'm just closing this one. Okay, so coming to Revit, here I just taken a small 3D model of a particular building. Okay, then RCC structure consists of 3 stories, and the footing here used is pile footing. Okay, so as we all know, Revit is purely a 3D modeling software. That means in Revit we can do, we have architecture tab, that means we can do architectural modeling. We have structure tab, that we can do structural modeling. We have steel tab, so from there we can create steel structures, warehouses, etc. And we can execute precast, and we have system tab, so we can execute MEP modeling and some other connectivity and modify tools, etc. there. Okay, so in Revit we can't execute analysis, we can only do a 3D model. Okay, but we can apply loads. Okay, so first of all I just explain how to apply loads in Revit in simple ways, not in detail. Okay, so for that we can go to analytical levels. Okay, that means it's actually 3D, and I'm going to 3D analytical. So analytical means what? In Revit we can create a physical model, physical 3D model, right? But in StatPro or Robot Structure or ETABS, we are creating what? Only analytical model. That is, there is no physical properties is present. Okay. So actually, this is an analytical model, which means simply like this is a column. Okay. In analytical model, column is actually we can see visualized by a single line or like a slab by like this. Okay. So this is simply analytical model. So here I just applied some of the loads. Just I will show you how to apply loads. So if I want to apply loads on this floor, so this ground floor, first floor, second floor. So I'm going to second floor level. Okay, second floor analytical. In 3D also we can apply load, but it's much clear. We can apply easily loads in analytical levels. Okay, so it's a so I'm coming to analytical levels, that is second floor analytical levels. And from here, analyze tab, we have a load option over here. Okay, so I just taking one load. Okay, so we can apply by three different ways, like loads, line loads, and area loads. So if there is a wall or a beam or something like that, we can apply the loads by line loads. Or if we want to apply live loads or slab loads, floor area, floor loads, etc., by area load method, or whichever whatever we want we can apply. Or like from properties we can choose the load, either it's a dead, live, wind, snow, anything we can apply. So now I'm just going to apply some dead loads. So dead loads are acting in which direction? Vertically downward direction. So from here we can choose which is the load we are going to apply. And right from here we have forces in x, y, and z direction as well. So normally dead loads are acting vertically downwards, right? So which is okay. So dead loads and live loads are acting vertically downward direction. So we can apply it in which direction is a direction, and it is downward direction. So that's why I'm taking -1. So after calculating load, hope you know how to calculate load. Load is, you can simply calculate load like by multiplying volume into density. So after that, you can just apply loads over here. If it is a wing load, okay, so it should act on which plane, x or y plane. So at that time, we can put values in x and y. Okay. So now I just applying 1 kilonewton load. So from here, I'm taking a hosted area load and I'm just applying here. Okay. So in this way, we can apply. I'll just show you in another level. Like I'm taking first floor analytical, and from here I want to apply loads. So in analyze tab, I just take load, and from here we can take area load or hosted area load. Both are same. If we are taking area load, we have to draw the area, and if we're taking hosted area load, we have to just pick the area. Okay, so that is the difference between both. Okay, so here after applying all the loads, we can just see in a 3D view. So load are just simply applied like this. Okay, so first of all you have to apply all the required load. Now here I just give some of the loads over here. So now I'm going to exchange the data with robot structure analysis. So the condition to exchange the data with robot structure analysis is both the software of same version. That means I'm here using robot structure analysis 2023 and also Revit 2023. Then only after there is like an add-in in structural analysis, there is an add-in should be added. It's not like a plugin or add-in we just downloaded from Autodesk learning app. Not like that. If we just install robot structure in our PC, so it's automatically here just added like an add. Okay, so the condition is of same version. Okay, so here I didn't open open structure yet. I just closed that window. It's it only opened. Okay, so now I'm going to exchange data with robot structure analysis. So I'm going to this option, robot structure analysis. So from there, choose the option robot structure analysis link and send model and direct integration. Why? Because I didn't open the software yet. So I'm directly send that model into robot structure. So I'm just you okay. So the modeling is sending to robot structure analysis. Sometimes it may take some time. So depends upon the capacity of software for a PC. Okay, so if you want to see the warnings or report, go for yes. Now I don't want that. Just give no. Okay, so it's directly open to which robot structure analysis, right? It's actually a 3D view. By rotating this view cube, we can rotate the view right from here. It's like 3D. If you want X, Y, Z or X, Y or X, Z plane or corresponding 3D, we can choose this option. Or right from here also we can choose either 2D or 3D. Okay, so it's like an analytical model just created. Suppose if you want, it's a like if we want to see like its physical properties, not like very clear like Revit, like in this view range also we can change that one. For example, the first option is node number. If you want to apply node number, you can just give. Okay, so all the node number should be visible. And here we have member number. So all the member number it's also like visible over here. And if the node support is added, only one is added. So while we are doing a fresh model in robot structure, we have just created support itself along with this one. This is actually for supports. And next about section shapes. Okay, so these are rectangular sections. That's why it's applied like rectangle. If you are taking a steel model like I sections or channel section or anything, the section shape should be visible. It's not perfectly a physical model, but almost a physical model. Okay, so next we have local systems. That means the local axis X, Y, Z axis. Next about panel interiors. If we given anything, you can see that option and load symbols. Turn off that one. Then load value descriptions. Okay, that all about. Okay, so coming here, we just exported and the load is everything is already assigned. Okay, that means from object inspector we can see all the stories and about members. Here we have two 11 members and about floors 87 and 151 nodes, etc., etc., available here. And coming here, it's a layout of the software. Now it's like geometry. If you want to take loads, for example, if we're doing a fresh model in robot structure, first of all, we have to create a particular geometry. Then we apply section properties. Then we apply loads, and finally we take what results. So before that, taking result in all of the analysis software, we just go for an analysis, right? So that we can find if there are any warnings or errors happening. So for that, go to analysis. So from analysis, we have analysis, types, calculation, etc. available. I'm going for calculations. Okay. Okay, and the calculations also take some time. Okay, hence we got the final result. Here we have what now errors. So the structure is okay. And but we have four warnings, and which is all listed over here. That is, there is some overlapped panel are there. The elements is not assigned to any story, and separate structure, the instability in user direction in the node 764. Okay, so some panels are like overlapped. Okay, so we have to resolve that one, but there is no errors, so that's why there's no need of revising that structure. And also there's an instability in user direction of the node 764. Okay, in 764 there is an instability. So if you want to know that, then we have to just turn on this node number. If you just turn on the node number, there is so many nodes after calculation. Like before that, we just turn on this node number, there is a few one, but because after no analysis there might show so many nodes. The reason because is it's not a model like created in the software, we just export it in another software. Okay, so the algorithms of both will be different. For example, like 72, it's 85. So in this way we have to find out which is a proper number, then you have to resolve that in Revit itself. Okay, why? Because we just created the parent model in Revit. So we just do for calculation, there is no error, then we can take result. So for taking result from geometry, we have to go for where results. So we have result diagrams, result maps, detailed analysis, extraposable. You can take any option. For example, I am going for detailed analysis. Okay, so right from here, if we want to take, yeah, now it's like dead load. These are the all loads and load cases we just added in Revit. Okay, and from here, if you want to know about like a specific member or a panels or objects, etc. Now I'm giving like all members. Okay, so the member numbers are also there, and I'm going to take NTM. NTM means normal stresses, shear stresses, and bending moment, etc. included. So from here, if I want to know all the forces, that's X, Fx, Fa, and Fz. And if you want to know the stresses, we can turn it from here. And also about reinforcement. From there, we can take a required or provided in different colors. And now about parameters. Suppose if you want to get the result by labels, we can go for this label option. Or if we want like text, we can go with this option. Or it's normally like a fencing one, we can go for this filling, and otherwise we can go for field filling, etc. If we want like field, I'm just go for that option. If you want to open with a new window like this, or we can like display in the same window, we can go for without a new window. Okay, so right from here we get the result of that particular member. Like it's like member 1 C5 column 5 is there, and it's only dead load. Why? Because from right from here we just apply only dead loads, and forces in X, Y is the direction is given here like in kilonewton. Okay, and we can see the maximum values and minimum values simultaneously. Okay, and it's also tabulated over right here. Okay, like a table. I'm just closing this one. Okay, this is the diagram. Okay, and right from here we just maximum value, maximum and minimum value in all fx, fy, and fz direction for case one, that is dead load only. If we just want like fence, can just apply. Okay, so the result we just get like a fence, and also the details by table in the bottom. Okay, now I'm only taking one value at a time. Okay, so the next part is if we want to tabulate or document all the results we get this software, we can just right click. So we get an option like screen capture. So after taking any results, we can go with it. Okay, now I just only taken forces, or if we want moment, then right from here we can take moments. Okay, or about stresses and shear stress, axial stress, bending moment, extra, we just get from here. Okay, then after that, if we want to document it, just right click, and one option we have screen capture is here. So just give screen capture. Okay, suppose I want to document it in a Word, so just copy to clipboard and give OK. Okay, and if you want to do just one word from here. Okay, so in different methods we can take documentation of this one. So here we just only exchange a loaded structure into a robot structure, and after that we just take the results. Okay, it's like in the software like STAD or ETABS, we can perform what simply modeling here and also analysis in the same software. Okay, so in our topic there is up to this is there. That means we just export a model and after that run analysis, then we just take the results. That's up to the topic. Okay, any doubts? Hello.
Hello.
Okay, you have any doubts? You have any concerns? Then you can ask.
Only Revit file can be exported to robot structure analysis, or AutoCAD 3D file also we can export.
No. Why? Because if there is some file extensions only support with some of the softwares, right? For example, in AutoCAD, there is some of the software which just like open. For example, if the Revit file format is .rvt, if we are doing a model file format, right, which we can't open in AutoCAD. Okay, so similarly, uh, we can't open all the files in other softwares. There is some classes like IS is there. That means international foundation classes. So if you
Mhm.
are exchanging data into that particular format, we can open it most of the BIM softwares. For example, in file we have export option. Then we have like IFCs available. Okay, so we can export to IFC and then we can open it into a suitable BIM softwares. Okay, then if we are just taking any 2D drafting view here, we can convert it into drawing or DX of DGN, which format. These all we can support in AutoCAD. Okay, and also in Revit we can export AutoCAD files. Okay, but it does not we can execute the same way we are doing in AutoCAD. That's not possible. But if you are doing a 3D model in Revit, we can insert AutoCAD file as a reference, only reference. Okay, that means insert we have import option there. So we can import CAD file over here, but
Mm.
it's like entirely acting as a reference. Okay, but we can pick planes. If we can pick grids or lines from that drawing. For example, if I'm importing an image, okay, we have import image option is here. If I'm importing an image, I can't pick anything in that image. It's completely a dummy, like in background. Okay. But if I'm importing a CAD file, I can pick the lines in that particular drawing. Okay, so that is the difference.
Okay, but in BIM industry, does anyone uses AutoCAD 3D, or the Revit only they are using?
Yes, why? Because in AutoCAD 3D is actually possible using suitable templates, but it is not growth in a large extent. Okay,
Okay.
like we can't create any only a basic 3D model simply by extrusion. We can just
Mm.
create a 3D model. Okay, and also the usage is not too much like friendly to create a 3D model in AutoCAD.
Okay.
So that is the difference, and also like only a simple tool is also available, and AutoCAD 3D like we can't take pick object in that particular UCS. Okay, that is the difficulty in creating a 3D model in AutoCAD, but it's possible. But coming to Revit, it's actually a multidisciplinary software. That means we can execute most of the disciplines in Revit itself. Okay, but it's like a drawback of Revit is there is no analysis possible, but there is connectivity with it. Okay,
Mhm.
there is some exporter like ISM exporter is there. Okay, it's actually exported from Revit to STAD. Okay, so if we are exchanging converted it into ISM, then we can do the same analysis as we done in our robot structure in STAT2. Okay, so the connectivity is actually there. Or if we are converted it into IFC format, we can just exchange the data to any other softwares. So that's
Okay.
it.
Okay, but one more question, madam. In Revit means the analysis is not available, means to perform an analysis. But there is option of applying loads and all everything, means point loads, and you just showed while before means why is it so? Means it's for the robot structure analysis, to perform robot structure analysis, or the different software is available any other for Revit, means.
Actually, I didn't get you once more.
No, the loads, applying loads, we can apply loads in Revit, just point loads and everything. So, but we cannot perform analysis in Revit, no, or we can
Yes,
perform.
yes,
Just we have to just export to robot structure analysis.
yes. That what I'm saying. Now I just export this in robot structure.
Hmm.
Other analysis tools are also there. Okay, that means that I said like STAD is a analysis software. If I want to exchange data from Revit to STAD, then we can use an exporter named ISM. Okay. So similarly, if I want to export it any other software, for example, there's a particular software. If I want to export this loaded structure, then there is an option I can convert this file format, this RBT file format to IFC, that is International Foundation Classes. Then we can open it in most of the BIM softwares. Okay, so the only application of applying load in Revit is for analysis, but there is not possible right from the software. We can export to any other analysis software to perform the same.
Okay, so in robot structure analysis, we cannot apply loads, or we can apply.
We can apply. Why?
Okay.
Because this is actually the parent model is here created in Revit,
Hmm.
right? So that we can just apply loads over here. Actually, robot structure analysis is actually an independent software that from there we can apply loads. For example, okay, here we have a load option is there. So
Okay.
using that load option, we can apply loads in robot structure. So first of all, we have to add loads. Okay, here the load cases shown here are we just apply in Revit. Okay, so if we are doing a model in robot structure itself. So first of all, we
Hmm.
have to create a suitable geometry like STAD, and after that, we just apply sections for that. Means if it is a concrete structure, we just put column sizes or beam size, etc. If it is section, then we just apply property. Then the next stage is applying loads. Okay, so right from here, we can just apply loads. That means the nature of the loads or sub nature all, but here the load details is it is in the parallel, sorry, parent software, which is just shown here. If we are doing a model freshly in robot structure, loads can be applied.
Okay, a new model also can be prepared in robot structure
Yes, yes.
analysis.
Robot structure is actually independent analysis software. That means we can create a model and we can do analysis itself in robot structure.
Mhm. Means
Okay.
in BIM industry, uh, what what is the preferred convenient way to use the robot structure? Just from exporting to
In
from
both
Revit.
ways we can use. Why? Because different companies use different software for what modeling. Okay, for example, uh, if a company just created a model in Revit, okay, then
Hmm.
like what they can export all the data to robot structure, then they can export sorry, perform the analysis, or they can take the data and using stat pro or etabs. There's another analysis software, okay, and stat pro from bentley and etabs from CSI. Okay,
Hmm.
so using that software itself, for example, I just opened Stat Pro, and first of all, I just created a model, and the data is which is similar in Revit. Okay, so we can create a model in that software, and analysis is also possible. Different method is there. Okay, so some companies use Stat Pro, some use ETABS.
E-types. Okay.
Okay, so it's actually depends upon different companies. Okay, any
Okay.
methods we can use.
Okay.
Okay, is it okay then? We can wind up.
Yeah, yeah. Yes.
Okay, thank you for joining.
Thank you, madam.